Another simultaneous equation, x plus 2y equals 11 and 3x minus 2y equals 9. So method 1, I'm going to maybe just draw it out. X plus 2y equals 11. Well, if x is a 1, that's 5, so 1, 5. So there's one of my points. If x was 3, x plus 2y equals 11. I think it's 3, 4. Okay, and there's that line. And then 3x minus 2y equals 9. So if we had, if x was 3, 0, and if x was 4, so if x was 4, so that's 12 minus, I'm going to say 1.5. Let's just see what that, 3, 0 is there, and 4, 1.5 is about there, and there's my 2 lines, and that looks like my point of intersection, and if my diagram was done more accurately, maybe I'd have a better idea. Are we going to say 5, 3? I haven't a clue. I don't think that's accurate enough for me to be confident in that answer, but I'm going to throw it out there, 5, 3. That's method 1. I'm not confident in that. I'm going to go for a different method. Method 2. Maybe you want to try adding your lines, subtracting your lines. Feel free to multiply a line by something. So x plus 2y equals 11 and 3x minus 2y equals 9. So I am going to add my lines. You know, really adding seems to have worked in the first question. It probably looks like it's going to work here too, because if you have 2y plus a minus 2y, well, what's a plus and a minus? It's a minus. So 2y and I lose 2y gives me 0, so great, that worked again, and that gives me 20. X is 5. But it doesn't always work. Adding doesn't always work. So try another method if necessary. Don't give up. Like try adding, try subtracting, maybe take a line and multiply it so that eventually these will cross off. If x is 5, then we look here. So then 5 plus 2y equals 11. So I now know that I took my top line all the way back up here. And I now know that x is 5. So I'm going to subtract 5 from both sides. Y is 3. So all I did was subtract y from both sides. And I divided by 2 and I got y is 3. Okay, so yeah, actually my guess was right. Well, I just wasn't confident in it. If I was in a rush inside an exam, maybe I just would have gone with that. But I have time here. So method 3. Sometimes the easiest method, even though in that first example I don't know did it look like it in the previous video. X plus 2y equals 11. 3x. So I'm going to take this equation because it just looks a bit easier, and I'm going to get the x on its own because the x is already on its own, and I just, as in there's no, like it's not 5x, there's no number attached to it, but you could get the y on its own, it'd just be a little bit more work. So if you subtract 2y from both sides, you end up with x is equal to 11 minus 2y. Hopefully you understand that this means that x can be replaced by 11 minus 2y. So if you look at your second equation, and you have an x, feel free to replace it with 11 minus 2y. I hope that makes sense. So there's the x in that second equation, and I replaced it with 11 minus 2y. I really like the maths in this type of method. I just think it makes an awful lot of sense to me anyway. So that's 3 times 11 is 33. That gives me minus 6y minus 2y equals 9. That's 33 minus 8y equals 9. I'm going to add 8y to both sides. I end up with 33 is equal to 9 plus 8y. I am going to subtract 9 from both sides. If you want to try this first, you just stop the video at any stage. 8y is equal to 24, y is 3. And if y is 3, well, go back to wherever you want, maybe your first line or even this line. X is equal to 11 minus 2y. Well, x is equal to 11 minus 2 times. We now know that y is 3. So x is equal to 11 minus 6, which is 5. There's my point of intersection.